Get out your weapons of math instruction.
Don't.
Because you're going to need a calculator for this one.
Oh, yeah. Oh, this is it. This is the real deal.
Why is it that the atomic masses on the periodic table are all decimals when you can't have like a half a proton or neutron?
Because it's a weighted average, I say, Monaco. It's a weighted average.
What the heck's that mean, Mr. Monaco?
That just means that your gym grade should not count as much as your math grade in your report card. That's really what that means.
But it does. Does it really? They count the same when they count the GPA, bro.
Oh, I don't know.
Bad example.
I don't know.
You ask.
Yeah, I don't think it works that way, but okay.
Huh?
Let's come on. Let's.
I was just trying to make you feel better, I think, Monaco.
Okay. Well, they're not as worth as many credits.
I have no idea what's going on.
Okay, learning targets. Here we go.
Learning target.
Whoa.
I can identify and define isotopes and calculate the average atomic mass of any given element, given two important pieces of information: the natural abundance of its isotopes and the weights of those isotopes.
Yeah, we are never going to figure out the natural abundances. You have got to use the information provided and just trust it. Please do not fight this one. Here's a picture of what we're talking about. 3 isotopes. I'm thinking hydrogen 1 is most abundant.
Well, yeah.
How do I know?
Because the average atomic mass of hydrogen is closer to 1 than it is of 2, or closer to or 3.
See how we did it? And it's math, and so let's do it. So an isotope is an atom with the same number of protons, but a different number of neutrons, giving it a different mass.
Yep.
Okay, good. The symbol and the atomic number remain the same, but notice the mass number changes, and that is in the picture, right? You got hydrogen 1, you got hydrogen 2, you got hydrogen 3. And what's changing in the picture is no neutrons, 1 neutron, 2 neutrons. See the difference?
I do.
Now we get to this whole piece called average atomic mass.
Boom.
Okay.
Go for it, Yanar.
This is that upper piece in the box that's talking about average mass, and that has to do with those naturally occurring isotopes. We have to calculate that, and you need 2 things. That's the mass of each isotope and how abundant it is, and that'll be in a percentage.
Mm-hmm. This is what the calculation looks like, okay? It looks terrifying at first, but we're going to show you an example. Leave a little space in your margin. Really not that bad. Okay?
Really not that bad.
Really not that bad. Let's keep it moving. Let's keep it rolling.
Yeah, do it fast. So
yes.
Step 1 says, let us multiply the mass, right?
Yep.
So let's do that. So there's the mass, boom, 12, and we're going to multiply it.
By its percent abundance.
By its percent abundance, but specifically in decimal form, because remember, percent is always part over whole times 100. So we got to get rid of that 100.
Yep.
We just want the part over the whole piece. So when I take this number,
I convert the decimal. You divide by 100 to move the decimal 2 spaces to the left. And it means that 98.89% of all carbon atoms have an atomic mass of 12.
correct.
So we have to make sure that our calculation accounts for the fact that
Most of it's
98, almost 99 out of 100 carbon atoms having a mass of 12, and only a very small percent have a mass that's different.
right. Because so if Monaco and I are pouring out carbon powder onto the balance, right, most of those carbon atoms are going to be 12, but every so often there's going to be a 13, and every so often there's going to be a 14.
Mm-hmm.
And we're just going to be a little bit more accurate and say it has an average atomic mass.
Mm-hmm.
So this mathematics, right, gives me an answer of 11.8668. I have to do it again.
But it's only part of the picture because you have to account for the other isotope,
which is carbon 13 in this case.
do the same process.
So the mass for carbon 13 is 13. I'm going to take this 1.1% though into decimal form.
Move that decimal, grab it, move it 2 steps to the left, put a 0 in
the spaces. You got it.
to
And now
hold
we
the
can
space.
multiply these together. Now I've done step 1. Step 2 says,
You're going to add up all of those products that you got in step 1.
there you go. So I'm going to add these up and I get an average atomic mass of 12.0111. And this is what's actually on the
periodic table. And this is why all the decimals on the periodic table are there.
Yeah.
Because every element has isotopes, and they're not all created equal.
And this is a perfect example now of you watching a video and being able to try the practice on your own that model this exact thing. Now, the first problem you do, you're going to not be so confident. but you're going to follow the steps the same way we just did.
Mhm.
The second one, you're going to be a little bit more confident. And by the third and the fourth one, you'll be like, okay, I got
Set it up
this.
exactly the way. Everybody hold up the calculation. Do it exactly this way,
Yes.
okay? Because that is how you do it. Atomic mass times the decimal version
Yep.
of the percentage, and you're off and running. You're good to go.
You are good to go.
I push the button and I turn it off. Push the button